This session, I want us to learn something on rigid motion or transformation, and this is for the junior high school students. So under rigid motion or transformation, always we use a graph sheet. And on the graph sheet, we have the y-axis and the x-axis. We have the vertical line and the horizontal line. This vertical line, we call it the OY or y-axis. This horizontal line is the OX or x-axis. So in an exam, you can choose either OY or y-axis and also OX or x-axis. Always for transformation 2, you will be given a scale which is 2 centimeters to 1 unit, or it can be 2 centimeters to 2 units, or 2 centimeters to 5 units. So whenever you are given something like this, they can say 2 centimeters to 1 unit on both axes. This means the y-axis will take the same scale and the x-axis too will take the same scale. But if you are given 2 centimeters to 1 unit on the x-axis, 2 centimeters to 1 unit on the x-axis, and 2 centimeters to 2 units on the y-axis, this means x-axis will take this scale and y-axis too will take this scale. So always you should note it carefully. But if you are fortunate and they give you 2 centimeters to 2 units on both axes, this means both axes will take the same scale. And the transformation to the graph sheet, this meeting point is called the origin. So we name the O. The meeting point is the origin. The origin. So this point is O. That's the origin. So always this is the positive side. So you name it 1. If you are giving 2 centimeters to 1 unit on both axes. So 1, 2, 3, 4, 5. Here 2 becomes 1. This side 2 is the positive. So the positive side. 2, 3, 4, 5. This is the negative side. So negative 1, negative 2, negative 3, negative 4, negative 5. So neg 1, neg 2, neg 3, neg 4, neg 5. You cannot write this one here, this negative side. Always this one, it should be in line with this one. So you writing it this here, like an examiner can penalize you. So always it should be in line. It should be in line. So neg 1, neg 2, neg 3, neg 4, neg 5. The reason why I am teaching this is that under transformation, you writing this will fetch you a mark, this too will fetch you a mark. Do not forget to label your axes, and also we always write our scale on the graph sheet. Don't forget to write your scale. It's very important, and also label your axes very well. So I want you to get a picture on how you will label your graph. So if you are given 2 centimeters to 1 unit on x-axis, let's take this. So 2 centimeters, 2 centimeters, 2 centimeters to 1 unit on x-axis, and 2 centimeters to 2 units on both axes. No, this is y-axis. What I first did was 2 centimeters to 1 unit on both axes. And this one, they have divided it. So I don't want any problem. So this is OY, OX. It's very simple. So the meeting point is O. 2 centimeters to 1 unit on the x-axis. This one will take 1, 2, 3, 4, 5. Here becomes -1, -2, -3, -4, -5. 2 centimeters to 2 units on y-axis. So this means we label here 2, 4, 6, 8, 10, 12. So you see, always if they say 1 unit, you start from 1, 2, 3, 4, 5. 2 units, you start from 2. So you'll be adding 2 to it. 2 plus 2 is 4. Plus 2, 6, 8, 10. So 2 centimeters to 5 units. You start from what? It will be 5. 5 plus 5, 10, 15, 20. So the scale is not difficult. You have here is -1, -2, -4, -6. Let me clean this one because some people may think it's negative, but it's not negative. It's positive. So -8, -10. So you label it 2 centimeters to 1 unit. X-axis. 2 centimeters to 2 units. Y-axis. So we knowing how to label our graph, we are now going to take certain headings under rigid motion. And the headings, we have 1. We have reflection. B, rotation. C, translation. D, enlargement. G, special marking. Special marking. We have these headings: reflection, rotation, translation, enlargement, and special marking. So I start with reflection. So under reflection, you should know this. Reflection in the x-axis. Under reflection in the x-axis, y is negative. And always for transformation, we leave our answer in coordinates. Take note. We leave our answer in coordinates. So if you are given 2, 3, this is the vector form. In coordinates, it is 2, 3, 4, 7. In coordinates, it's 4, 7. Most people always leave their answer in the vector form, which is wrong. This is the vector form, and this is the coordinates. But always, this one is right. So reflection in the x-axis, we negate y. Take note, negate y. Reflection in the x-axis, negate y. So this is the original coordinates. So it becomes x neg y. But this is in the vector form. The coordinates becomes x, negative y. So this is the formula. So always reflection in the x-axis will negate y. Example 1. The point A, 1, 2 is reflected in the x-axis. find the new or find the image. So we know reflection in the x-axis, you negate what? Y. So it becomes x neg y. X neg y. What is the point? A is what? 1, 2. And always, if you don't want to be confused, label your coordinates. So the first one is x. This is y. We don't have AB. Always on the graph sheet, we have the y-axis and the x-axis. That's why the coordinates is always x and what? Y. So reflection in the x-axis, you negate your y. So this becomes a prime 1. What is your y? It becomes -2 because reflection in the x-axis, you negate y. So it becomes 1 neg 2. The new image now is 1 neg 2. The second example, the same question. If I change this and make it P, so P 3 neg 8 is reflected in the x-axis. Find the image. So we know P is 3 what? Neg 8. So the image, it becomes 3. You see, you negate y. And once you are negating y, the negative becomes 2. Because if you negate it, we have one negative here. So it becomes positive. So we have 3, 8. Once two negative signs meet, it becomes positive. Take note. Another example. So this was 2, 3. The points are 2, 5 is reflected in the x-axis. Find is or find, this is r, so find r complement. It's the same as find its image. So reflection in the x-axis, y is negative. Y is negative. 2, 5. We know this is x and this is what? Y. So it becomes 2 neg 5. We negate y. So this is vector from leaving it in coordinates, it becomes 2 neg 5. So I'm done with reflection in the x-axis. Now let's move on to reflection in the y-axis. Reflection in the y-axis. So under reflection in the y-axis, you negate x. Reflection in the y-axis, you negate x. It becomes xy maps to, so this becomes negative xy. But this is in the vector form. Leaving it in coordinates, it becomes neg xy. Reflection in the y-axis, you negate x. Example 1. The point 2, 4 is reflected in the y-axis. Find its image. Take note that there is a difference between rigid motion and transformation. Under rigid motion, the size or shape of the object will not change, but transformation, it will change the size. So reflection, rotation, and translation, they are all rigid motion because the size or shape of the object will not change. But under enlargement, it's under transformation. Enlargement is a transformation because the size of the object will what? Change. So take note. So transformation. So let's come back to our example. So this is reflected in the y-axis. We have x, y maps to. So you negate your s. becomes -2, 4. So -2, 4. Example 2. The point M, -3, 7, is reflected in the y-axis. Point M complement. So we know this is x and this is y. Resolving, it becomes -3, 7 maps to reflection in the y-axis will negate x. So you negate this one, so it becomes -3, 7. But once two negative sign is meeting, it becomes positive. We have 3, 7. This is in the vector form. Coordinates, it becomes 3, 7. You can make this question in an objective, or once you will show working in section B, this is how you work it. But in an objective, once you know the formula, there is no need to work. You can choose it straight. Now the third one is reflection in the line x is equal to 0. Third one, which is C. So we have reflection in the line x is equal to 0. So under reflection in the line x is equal to 0, we negate x. Take note, anytime you hear of x is equal to 0, negate your x. It becomes xy. This is the original point, which is xy. So in the coordinates, it becomes xy. This is reflection in the line x is equal to 0. Example 1. The point 2, 3 is reflected in the line s is equal to 0. Find its image. We know this is x and this is y. And anytime you hear of x is equal to 0, negate x. Do justice to it. Always people get confused if they say x is equal to 0. But at the senior high level, they can give you reflection in the line s is equal to 2, s is equal to 3, s is equal to -4. We have a formula for it. But once they give you reflection in the line s is equal to 0, you just negate what? X. So we are having 2, 3. What is your x? X is 2 and y is 3. So you negate your x. So you have -2, 3. It's not difficult. So this is 1. Let's change the values. Let's make here r -4 and this is 9. Find its image. So what is x? X is -4 and y is 9. So we have -4. So 9. Once two negative signs is meeting, it becomes positive. So we have 4, 9, which is 4, 9. So this is reflection in the line x is equal to 0. We have another one, which is reflection in the line y is equal to 0. And once x is equal to 0, and I make mention of y is equal to 0, what comes in mind? This means this one will negate y. So y is equal to 0, negate y, x is equal to 0, negate x. It becomes xy, maps to x neg y. So this is x neg y. This is the coordinates. Always do not forget to leave your answer in the coordinates form. Under transformation, we leave our answer in coordinates but not vectors. Take note. So example 1. The point 5, 10 is reflected in the line. In the line y is equal to 0. Find its image. The first thing you are supposed to do is that you must identify your x value and your y value. Once you are through with this, you move on to your formula. Now you know y is equal to 0. You negate what? Y. You negate y. And you are given 5, 10. You know our x as 5 and y is 10. Once we are negating y, it becomes 5 and 10. But if here was supposed to be negative 10, this means it becomes negative 10. And once two negative signs meet, it becomes positive. But here is the case, the 10 is positive. So you just negate your y. So you have 5, negative 10. The next one, using the y-axis as the mirror line. This is the same as reflection in the y-axis. If they want to confuse you, they will bring using the y-axis as the mirror line. Please don't get confused. It's the same as reflection in the y-axis. And we know under reflection in the y-axis, x is negative. You negate x. So if I give you an example, using the y-axis as the mirror line, find the image of the point R to 5. So this is the same as reflection in the y-axis. Don't get confused. Solution. We know reflection in the y-axis or using the y-axis as the mirror line. We negate what? X. So it becomes x, y. Now what is your x value? It's 2. Y value is 5. You have 2, 5. So it becomes negative 2, 5. Which is 2, 5. So always, if they give you using the y-axis as the mirror line, it's the same as reflection in the y-axis. Take note. They just want to confuse you. Again, we have the next one as using the x-axis as the mirror line. So I just change it. So this is x. Using the x-axis as the mirror line. X, this is the same as reflection in the x-axis. So I'll be changing the formulas. So you negate y. You negate this y. If you are given using the x-axis as the mirror line, this is the same as reflection in the x-axis. And reflection in the x-axis, you negate y. So sy maps to x neg y maps to x, neg y. Example. Let's work out this example. 1. The point so using the x-axis as the mirror line, find the image of the point 6, 9. Now what is our x value? X value is 6 and y value is 9. This one becomes, we have xy using the x-axis as the mirror line. So you negate y. It becomes x neg y, which maps to x, negative y. We know our x value as 6 and y value as 9. 6, 9 maps to 6 neg 9, which maps to 6, negative 9. So under reflection for the JHS, this is where you should know up to. But under the senior high school level, we have reflection in the line S is equal to A, reflection in the line Y is equal to A, reflection in the line Y is equal to X, reflection in the line Y is equal to negative X. There are many. So for the JHS students, please note this carefully under reflection. I want us to know the formulas, and after that we will move on to the graph sheet. But please take note. Under reflection, this is all that you should know. We have reflection in the x-axis, and we know under reflection in the x-axis, y is negative. Reflection in the y-axis, s is negative. Reflection in the line s is equal to 0, we negate x. Reflection in the line y is equal to 0, we negate y. Using the y-axis as the mirror line is the same as reflection in the y-axis, so you negate x. Using the s-axis as the mirror line is the same as reflection in the s-axis, so you negate y. So this is a summary for reflection. Now we are moving on to rotation, and under rotation is very simple. Castro will make rotation very simple for students. B, I'm having rotation. Under rotation, we should take note of these key concepts. We have the clockwise and 2 anti-clockwise. Let me use a normal clock to explain a clockwise and anti-clockwise. We know this is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We know always our clock, it moves in the clockwise direction. It moves in the clockwise direction. This is the clockwise direction, so this is clockwise. Because always under clockwise, it starts from the least. So 1, 2, 3, 4, 5, 6. Anti-clockwise 2 starts from the highest. So anti-clockwise. I believe now we have understood clockwise and anti-clockwise. Our watch or clocks in our homes moves in the clockwise direction. And under clockwise, it starts from the least to the highest. But anti-clockwise will start from the highest to the least or lowest. So always for rotation, we have some angles of rotation. And under the angles, we have 90 degrees, 180 degrees, and 270 degrees. Take note. 90 degrees, 180 degrees, 270 degrees. We have 90 degrees clockwise, 90 degrees anti-clockwise. We also have 180 degrees clockwise, 180 anti-clockwise, 270 degrees clockwise, and 270 degrees anti-clockwise. I will use a nice table to explain the formulas for clockwise 90. All this, I'm going to use a table, but please get the understanding of clockwise and anti-clockwise for me, and I believe students, you have understood it. So, for my table, if we take clockwise and anti-clockwise in an alphabetical order, what comes first? We know A comes first because A, B, C, D. Anti-clockwise is first. After that, we move on to clockwise. So anti-clockwise first. Anti-clockwise and clockwise. So under anti-clockwise, we have now the angle of rotation. We have 90 degrees, 180 degrees, and 270 degrees. We know for the anti, it starts from the highest to the lowest. This means I'll start from 270 degrees, 180 degrees, and 90 degrees. Clockwise 2 will start from the lowest to the highest, so 90 degrees, 180 degrees, and 270 degrees. There is no way they will ask you a point is rotated through 40 degrees clockwise. No. Then I don't know whether they are going to develop a method for that one too, but no, it's not possible. So now we know this. Anti starts from the highest to the lowest. Clockwise starts from the lowest to the highest. We know the original coordinates as x, y under transformation. So we are now going to rotate. Like if you take this marker pen, if I rotate, it becomes like this. So you see I'm rotating, you will be turning it upside down. Once I rotate this, it becomes yx. I'm turning it. And once I have turned this one, I will turn this one. If I turn this one upside down, it becomes what? xy. So you'll be rotating it to the end. This one too becomes yx. So you see this point was xy. Here is yx. You rotate this, it becomes xy. You rotate this, it becomes yx. And once we know this, you construct a zigzag backwards. Zigzag backwards. And constructing a zigzag backwards, it becomes something like this. And this is the original coordinates. So you won't construct this line up to this point. No. Because it won't affect the original coordinates. We are rotating this coordinate to get the formula. So where the line passes through, wherever this line passes through, you negate it. So this time, this means you negate this, and this. That's our formula. So if you take anti-clockwise 270 degrees, it's the same as clockwise 90 degrees. The formula is y net x. Anti-clockwise 180, clockwise 180 is the same as negative s, negative y. This 180 degrees is the same as half turn. Half turn about the origin. If you use something like this, is the same. So 180 clockwise and anti-clockwise, it becomes negative s, negative y. Anti-clockwise 90 degrees is the same as clockwise 270 degrees. The formula is negative yx. Always take note that if the direction of rotation is not given, it is anti-clockwise. Take note. Always, if the direction of rotation is not given in the question, like they can give you a point is rotated through 90 degrees without giving you whether clockwise or anti-clockwise, it's anti-clockwise. So now, let's write down our formulas. Let's write down our formulas. We have anti-clockwise 270 degrees is the same as clockwise 90 degrees. So we have A. So xy maps to y net x. That's the formula. So y net x. B. Anti-clockwise 180 degrees is the same as clockwise 180 degrees. So we have xy maps to neg xy maps to neg x neg y. C. So you see, I'm writing down the formulas. C. Anti-clockwise 90 degrees is the same as clockwise 270 degrees. So xy maps to negative yx maps to neg yx. And take note, 180 degrees is the same as is the same as half turn about the origin. And as I said, if the direction is not given, if direction for rotation is not given, it is anti-clockwise. So now a brief summary for the table. Now we know the direction of rotation is clockwise and anti-clockwise. And under anti-clockwise, you must start from 270, 180, 90. Because anti-clockwise, you start from the highest to the lowest. And the angles of rotation are 90, 180, and 270. Clockwise, you start from the lowest to the highest. So 90, 180, 270. So this is the original point. You will be turning this one upside down or rotating it. So SY, it becomes YX. This YX, you turn it upside down, it becomes XY. And this one will be turned upside, it becomes YX. So you construct a zigzag backwards. And wherever the line passes, you negate it. And I have written down my formulas. So this is what you should take note under rotation. So I'm coming to give an example under this, about 3 examples under rotation. And when we move on to the graph sheet, we will be writing down the formulas. But I just want us to solve for 4 examples or 3 examples. Examples under rotation. 1. The point M, 1, 2 is rotated through 90 degrees clockwise about the origin. Find its image. So 90 degrees clockwise. 90 degrees clockwise. The formula xy maps to y net x. That's the formula. So what's the point? It's 1, 2. This is our formula. So it becomes you are given 1, 2. So what is our y? Y is what? 2. X is what? Negative 1. You negate it because the formula is y net x. So we have 2, negative 1. That's the formula. Example 2. The second example. Example 2. The point R, 3x is rotated through 270 degrees about the origin. Find its image. You see now, for this question, they didn't give you the direction, whether it's clockwise or anti-clockwise. But I said, always if the direction is not given, it's anti-clockwise. So the formula, it becomes, this means it's 270 anti-clockwise. And we know 270 anti-clockwise is the same as 90 degrees clockwise. So the formula becomes y net x. And you have been given r to be 3 net 6. So we have, what is y? Y is negative 6. What is our x? X is what? 3. But x, the formula, we negate it. So it becomes net 6 net 3. So R1 net 6 net 3. That's our answer. Now let's move on to the last question. The point Q, negative 5, negative 7, is rotated through a half turn about the origin. Find its image. This is the same as 180 degrees. And for this question too, they didn't give you the direction. So this means it's 180 degrees anti-clockwise. So we have the formula to be xy mapped to net x net y. So it's net x net y. What is the value of
x. X is -5 and y is -7. So -5, -7. So we have negative, -5, negative, -7. So it becomes +5 and +7. This is scale. So we have here a scale 1. That's the answer. +5, +7. So I'm done with rotation. We also have a heading called enlargement from the origin O under transformation. And under enlargement, they will give you scale factor. Scale factor. So if they give you the point x, y, we know this is the original coordinates, is enlarged from the origin by a scalar factor k. The point xy is enlarged from the origin by a scalar factor k. This is what you do. So xy maps to this scalar factor is a number. But now I want to use variables or letters to illustrate it. This variable will multiply the coordinates, so it becomes k, x, y. And this is the same as k times x, k times y. So you have kx, ky maps to kx, ky. That's our named image. So always, if you are given a scale factor, you multiply the scale factor by the coordinates. 1. The point 27 is enlarged from the origin O by a scalar factor 2. Find its image. So this is scale factor 2. We know the formula to be xy maps to k xy, which will give us kx ky. Now what is our x value? X is 2, y is 7. So we have 2, 7. And the scalar factor of what? Scale factor is 2. So 2. We have 2, 7. It becomes 2 times 2. 2 times 7. Because these two will affect the x value and also the y value. So you have 4, 14. This is in the vector form. Writing it in coordinates, it becomes 4, 14. That's the answer. Example 2. They can also give you here as -3, -3, -5. It's enlarged from the origin O by a scale factor -1. Find its image. It's the same formula. It becomes -3, -5. And this will give us the scale factor is -1, so we have -3, -5. This -1 will multiply the -3 and also the -5. So negative times negative, we know is positive. Applying integers. This times this is +3, this times this is +5. So you have 3, +5. So always on the enlargement from the origin, take note that you will be given a scale factor, and the scale factor you will multiply it by your coordinates. So it's not difficult to take note. This is all that I have under enlargement from the origin. Let's move on to translation. The next one is special mapping. Even though I should have treated translation as the third one, after that I will come to enlargement and the last one will be special mapping. But I want to treat translation as one session. So take note. Let's do special mapping, and translation will be seen in my next lesson. So under special mapping, you will be given a formula. Special mapping. you are given xy maps to x plus y, x, this is the formula. You will just follow the formula. If I give you find the image of 2, 3, this means you locate your x and y value. This is x and this is y. Now the formula is sy maps to x plus y, x. So what is our x value? X value is what? 2. And y is what? 3. This x is what? 2. So 2 plus 3 is what? 5. We have our top value as 5 and down value as 2. So it's 5, 2. And the special mapping, always you will be given the formula. We are having this as the root. So it becomes xy maps to have x plus y, 2y. And we have 8, 4. So we know x as 8 and y as 4. So half 8 plus y is 4. So 2y is 4. So half of 8 is what? 4. So it's 4 plus 4. 2, 4. So 4 plus 4 is what? 8. 2 times 4, 2 is 8. So we have 8, 8. That's the answer. So always under special mapping, take note that you will be given the rule or the formula so that you will substitute your x value and the y value and you will work out for the points to get a new image. So this brings us to the end of today's lesson, and in our next lesson I will teach you translation, and you will really appreciate how I will be teaching translation. Thank you.